All right, so I think I'm recording. Let's take a look at solving this inequality. With the word and, we could write it as a single inequality, a compound inequality. Here with the word or, we want our solution set to either satisfy the left inequality or the value of x that satisfies the right-hand side. So it's possible that x may not satisfy both of them at the same time. If you wanted to satisfy both at the same time, you would have the word and there. You want to satisfy this and the other. So in mathematics, and or have a different meaning. You'll hear and referred to as the intersection and or referred to as the union. But we're not going to get that detailed. All right, so let's split this into two problems. On the left-hand side, or excuse me, on the left here I have 10x plus 8 is greater than or equal to 18. Let's solve this. We want to get the variable by itself, so let's subtract 8 from each side. If I subtract 8 here, I want to subtract 8 here, and the negative 8 and positive 8 cancel each other out. And what we have now is 10x is greater than or equal to 18 minus 8 is 10. So let's divide both sides by 10. 10 divided by 10 is 1. So on the left-hand side, I have x. And on the right-hand side, well, I've got 10 divided by 10, and we said that was 1. Or, let's take a look at this second inequality here. 7x minus 3 is less than or equal to negative 10. And we want to try and do the same thing, get the x by itself. So let's add 3 to each side. The negative 3 and positive 3 cancel each other out. So we have isolated the term that contains our variable. Negative 10 plus 3 is a negative 7. Be careful here, to get the x by itself, we want to divide both sides by a positive 7. And 7 divided by 7 is 1. So on the left-hand side, I have x, and this is less than or equal to negative 1. So if you think about what this means, it's not asking us to graph it on a number line, but it certainly doesn't. In mathematics, it always helps to draw a picture, and this graph is a picture to help us understand what's going on. Greater than or equal to 1, well, here's the number 1, so if it says equal to, we draw a solid dot. Greater than, we're interested in the numbers that are to the right of positive 1. Or x less than or equal to negative 1, you have here x less than negative 1. So pick a number that's in the shaded region, and you're guaranteed to satisfy at least one of these inequalities. So I hope that helps, and I will talk to you later.